When two triangles are congruent, that means that all three corresponding sides are the same length and all three corresponding angles are the same size. So that's 6 different things that need to be checked. However, we as mathematicians are very, very lazy people. We don't want to check 6 things if we don't have to. So the question is, how many things can we check that keeps the number of checks small but still proves congruency? It turns out that 3 is about the minimum you need in order to prove that all 6 measurements end up matching in the end. So here are different possibilities of 3 things that you can check. So when you see the letter A here, that means angle. S stands for side, and the order in which the letters are listed matters. For example, when you see here that it says SAS, that means I have 2 sides and the angle between them. So what we're going to do is we're going to run through these options and decide whether we think there's enough information to prove that these triangles are in fact congruent. So here we go. Let's start with SSS. If I know that, I have one set of matching sides and a second set of matching sides and a third set of matching sides. Is that enough to prove that the triangles are congruent? What do you think? We haven't measured any angles yet, but let me ask you this. If I gave you a stick of this length, a stick of this length, and a stick of this length, would it be possible for you to make any other triangle? As we think a little bit, I hope you come to the conclusion that, well, no, there's really only one way to put those 3 lengths together. Even if you say switched the position of the 1 and the 2 side, well, that's just the same triangle flipped over. It's still got the same side lengths and the same angles. So yeah, these 2 triangles are in fact going to be congruent. So if you know that you have 3 sets of matching sides, you, my friend, have 2 congruent triangles. Let's run through the next one. What if I have SSA, so a set of sides that match, another set of sides that match, and then an angle that matches. Now remember, the order matters. So side to angle means I'm talking about this angle right here. Side to angle. If this is what I know matches, is that enough information to be able to prove that these 2 triangles are congruent? Now, as the pictures are drawn here, you may say, well, yeah, right? Don't these look the same? But imagine you didn't have the picture in front of you. If I gave you this angle and this side labeled 2 and said, all right, now you've got this other side with the 1 mark off the end of it, I want you to make a triangle. It turns out there's actually 2 different options. Notice the difference. So here's that side, here's that angle, here's that side, here's that angle. If you hadn't seen a picture of the triangle before, you could make a triangle like this with a big angle at the top, or you could swing this side around over to here and make this triangle with a small angle at the top. And because we don't have any information about what that top angle is, you don't know which one of these 2 you're supposed to make. If it's not super clear, locked in, ironclad, if there's not just one triangle that can be made, it turns out that no, SSA, side angle, that's not enough information to prove 2 triangles are congruent, because there could be 2 different ones that have matching SSA. Now, an easy way to remember that that one doesn't work is you just look at what it spells if you read it backwards. Let's now look at the next option. So I'm going to leave the middle ones there. That's to remind us that SSA doesn't work. So I'm going to put here SSA with the sad face. Now let's look at SAS. So if I know that I have a set of matching sides and then a set of matching angles, remember the order matters, and right after that, another set of matching sides. Okay, well, let's imagine, just for a moment, that that was the only information that you had, right? If I give this to one student and this to another and say, all right, finish the triangle, they both have to draw the same line segment. There is only one option. They're going to draw that, they're going to draw that. Two segments that are the same length and the same orientation. Turns out that, yeah, SAS is going to work. If you have a side and another side and the angle between them, there's only one possible way to draw the third side. So we can prove the two triangles are congruent using that method. Let's keep going. This is kind of fun. Let's check now ASA. So I know I have a set of matching angles, then a side, and then another set of matching angles. So all a student would know is I have to make a line ray that goes in this direction to make that angle, and I have to make a line ray that goes in this direction. The question is, are they always going to meet at the same spot? I hope I can convince you without too much trouble that yes, that is going to happen. Probably want to bring the lights back a little bit. Thank you for your understanding there. Yeah, I mean, let's just imagine this situation. If I told you you got this side, and you have a side that has to go at this angle, and a side that has to go at this angle, then when you extend them, you don't have a choice. They're all going to meet at that same spot. So yeah, ASA also gets us a set of congruent triangles, because if you know two matching angles and a side in between them, there is only one way to finish out the triangle. Well, that's pretty cool. Okay, let's keep going. Let's check next AAS. AAS looks like this. I've got an angle that matches another angle. And then I move to the next angle. I know those match. And then I have information about a side that isn't between the two angles. That's important. Remember, the order of the letters makes a difference. The question is this enough information to prove the triangles are congruent? The answer is yes. Here's how we know. Because in a triangle, all the angles add up to 180 degrees. If I know two of them, I can subtract those two angle measures from 180 to figure out what the third one is. And if I use the same two numbers again, I'm going to get the same result again. And look at this. Now it's angle, side, angle, ASA, which we already know gives you just one set of triangles that works out. So sure enough, AAS is also a method you can use to prove two triangles are congruent. All right, just one more to check here. That's AAA. So that would be this situation, where I know that I've got two triangles and all of the angles match up. What do you think? Is that enough information to prove that the two triangles are congruent? Consider this situation. Here, I've got a triangle with an angle that goes like this. Well, the same angle is over here. This angle up top, well, that's the same angle as up top over here. This angle down here is the same as this angle down here. Are those two triangles the same shape and size? No, they're not. If you know all the angles match, then you can prove the triangles are similar, but without information about at least one side length, you don't know that they are in fact the same size. So unfortunately, to prove congruence, angle, angle, angle isn't super helpful. So here's our summary. If you want to prove that two triangles are congruent, these are the methods that are going to get there for you. SSS, SAS, ASA, and AAS. Now, which one is better or worse than the other? Completely depends what information you have. In the next recording, you're going to see some sample practice problems, and we'll get a better sense then of how exactly all of this works together.